Okay, so the final problem of this problem solving series. So we are going to be doing 4.34 from Ohm. So a causal and stable linear time invariant system, S, has a frequency response of h of j omega, which is defined below. Defined really ugly. Oh my gosh. 6 minus omega squared plus 5 j omega. Okay? And so A wants us to determine the differential equation that is relating the input x of t and the output y of t. Okay, I'm going to write that down for you because I'm going to make these notes PDF. I'm going to make it available for y'all. So determine diff EQ for x of t and y of t. Okay. So what you have to realize here is that h of j omega is equal to y sub j omega over x of j omega. Okay? Which is then equal to everything here belongs to x and everything here belongs to y. Okay? So what you want to do is you're going to move this back to the other side, to the other side to get your differential equation. So I'm going to show you what I'm talking about here. So 6 minus omega squared plus 5j omega is going to be equal to make this more obvious. So we're moving this back over here to make that to y sub j omega. Moving this back over here to make that to x of j omega. Okay? So this is y sub j omega times all that. And that's going to be equal to x of j omega times all this. Alright. So, seeing the differential equation is getting pretty easy here now, okay? But the one thing that's going to confuse a bunch of people is how to change this into some sort of j omega so you know if it's a d squared or just a d. I mean, obviously it's going to be a d squared because it's omega squared, but I want to show you that j squared is equal to -1. So you can flip-flop the two, turn the -1 back into j squared, and so then now we're going to have to be 6 plus j omega squared. All right. So let's go ahead and change this back. So we know that y sub j omega is equal to y sub t. And 6. Oh no, the Apple Pencil died. I'm gonna just talk to you while it charges for a couple seconds. And so the 6 is gonna drop down. The j omegas are gonna turn into the differentiators. So just j omega turns into d dt, while j omega squared will turn into d squared over dt squared. And the same thing is going to go for the x of j omega side. So j omega is going to turn into a derivative, while the 4 is just going to turn into a constant, okay? So let's go ahead and write that out, what I just said. 6 plus d squared dt plus 5d dt is going to be equal to x of t d dt plus 4. Okay, now let's distribute it all out. So we're going to have d squared y sub t over dt plus 5dy sub t dt plus 6y sub t is going to be equal to dx of t dt plus 4x of t. And so that is going to be your differential equation for part A. Alright. So now let's see what part B wants from us here. Okay, so part B is asking for determine the impulse response of S. Okay? So the impulse response, as stated in an earlier video, I'll restate it. Let's circle all this for you guys so you can know what the answer is. Okay, so part B. Alright, determine impulse response, which is going to be h of t. That's what the impulse response is, okay? H of t is going to come from the inverse Fourier transform of h of j omega, which nicely was already given to us. H of j omega is going to be equal to j omega plus 4 over j omega squared plus 5j omega plus 6. Okay, first, as you guys can see, this is pretty ugly, so we need to change it using v substitution. So j omega is equal to v. Okay, so then we have v plus 4 over v squared plus 5v plus 6. Alright, just a little tip for you guys that's a little off subject, but I'm just going to go ahead and try to throw it in here for you. If the numerator degree power, so like v to some n is equal, why does my iPad keep moving like that? Is greater than or equal to denominator vn, then it is improper, and you must do a division, exponential division. Okay, so or as other people know it as long division. Okay, same thing. Okay, but it is not improper because this is a power of 1 and this is a power of 2 on the bottom, so we're good to go. So this is going to turn also into partial fractions. A over something plus b over something. So we know that this is going to be v. So what times what equals 6, but adds to give 5, and that's going to be 3 and 2 plus, so a over v plus 2 and b over v plus 3. Okay, so let's go ahead and solve this. So we know that it's going to be a v plus 3 plus b v plus 2. So we know that there is a variable and just a constant in there, so AV plus BV is equal to 1V. Cancel out the V, so we know that A plus B is equal to 1, okay? And we also know that 3A plus 2B must be equal to 4. Okay, so let's go ahead and do a simple two equations, two unknowns solving. Okay, I can already see it right now. A is equal to 2 and B is equal to -1. So since A is going to be equal to -B, you plug that in. So we're going to have 3A actually, yeah, 3A what am I doing here? Oh, okay. Actually, let's just multiply this by -1, or times this by 2, -2. So then we're going to have, and then you subtract them, so you're going to have A plus 0B is going to be equal to 2. Okay, and since you know that A is equal to 2, you can plug it in and you'll find out that B is equal to -1. That's an easier way to solve that, okay? Alright. So now that we have that, let's go ahead and erase all that and plug these values back in. So 2 over B plus 2. We're just going to go ahead and substitute the j omega back in. So j omega plus 2 minus 1 over j omega plus 3. That is going to be equal to h of j omega. Okay? So now we have to do the inverse Fourier transform. Okay? And we know from the sheet this is going to be 2 times e to -2t use of t minus e to -3t use of t. Okay? So you'll end up memorizing it. I didn't even have to look at the sheet for that. And this is h of t, which is the impulse response. Okay? Got this from the sheet, just to let you know. Okay? So now, the next part of the question is asking, what is the output of S when x of t is equal to a certain something? So, C. What's output of system when x of t is equal to e to -4t use of t minus te -4t use of t. Okay, so I can already tell that this is going to be 1 over j omega plus 4 minus 1 over j omega plus 4 squared. Okay? So the output of a system, the output is equal to S, which is equal to y sub t, which you can get from the inverse Fourier transform of y sub j omega, and y sub j omega is equal to x of j omega times h of j omega. Okay, and we have both of these, so we can just multiply them. X of j omega is equal to this. Okay, so let's go ahead. Plus 4 divided by j omega plus 3 times j omega plus 2 all times by 1 over. So let's simplify the x of j omega first, make it easier on us. So x of j omega is going to be equal to j omega plus 4 minus 1 all over j omega plus 4 squared, turn into a 3. Okay, so this is our h of j omega right here. X of j omega is going to be j omega plus 3 all over j omega plus 4 squared. Alright, and when you're multiplying these, I know we can all see that some of these cross out. Bam, bam, and bam, bam. So what we are going to be left with loss of j omega is going to be equal to 1 over j omega plus 2 times 1 over j omega plus 4. Okay, this is going to turn into another partial fractions, doing v substitution. So it's going to be 1 over v plus 2, v plus 4. So a over something plus b over something is going to give us something. So v plus 2, v plus 4. So a is going to be equal, a b plus 4 plus b plus 2. So AV plus BV must equal 0, and then 4A plus 2B must equal 1. Okay, so we're going to times this by negative 2. So we're going to have 2A equal to 1, so A must equal 1/2. So, and then you plug this back in there, and we can see that B is going to equal to negative 1/2. These are our two answers for A and B. Alright, and let's plug it in. So A is going to be 1 over 2 times 1 over j omega plus 2 minus 1 over 2, 1 over j omega plus 4. Okay, almost done, guys. So this is y sub j omega. So now we have to do the inverse Fourier transform, which you can get from your sheet. You should have memorized by now on this. E to the negative 2t, u sub t, minus 1/2 e to the negative 4t, u sub t. Alright, and that is going to be your y sub t, which is the output of system. Okay, let's go ahead and circle this all for you. And I will make this note with all the other answers on it as well available on his website. So let's go ahead and just talk through this one more time, just so you can kind of get the gist. This is a very important formula to know right here. You need to understand it, okay, and what it looks like. Then you can easily determine the differential equation. That's an easy part, okay? Partial fractions is going to be a big part of this. You need to understand how to do it. And once you find h of j omega, the hard part's done. You just have to look at your sheet to find the impulse response and the time domain. And same thing with the output. Like I said, use this h of j omega. Okay, it will save you a bunch of time and give you the right answer every time. This one you do not want to use. Do not use that. That's wrong. I mean, it's not wrong, but it's not in the most simplest form to where you can easily solve. Okay? And that's going to be everything. Hopefully all these videos